Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if x belongs to a group and order of x is given to be 6, then they are asking to you that find the order of x square, x cube, x raised to power 4 and x raised to power 5. Right, this is one part of the question. So if you remember the definition of order of an element, it is the smallest positive integer such that when let's call it to be n, such that when you raise it to the power n, you get identity element, correct, of the group. Now because we are given the order of x as equal to 6, so what does it mean? It means that we have x raised to power 6 as equal to e. So we have to make use of this fact to calculate what is the order of x square, x cube, x raised to power 4 and x raised to power 5, correct? So let's start with this thing here. So it is very simple in order to calculate the order of x square. Why? Because when you raise x squared to the power 3, what do you have? You have the power as 6 because 2 is multiplied with 3, and we already know x raised to power 6 is e, so this thing becomes e. So that means when you take the third power of x square, correct, you get e, hence the order of x square is 3. Similarly, for x raised to power 3, when you raise it to power 2, you get again the power of x as 6, which is e, you know from this expression, hence the order here of x cube is 2, right? What about x raised to power 4? So we have to think it like this. So we have to make it as 6. If the number cannot be made as 6, we have to make it some multiple of 6. So can we make it 12? Can we make it 24? Can we make it 30 and so on? So you have to look at the number like this. Now you have 4. What power should I take here instead of this x raised to power 4 so that I get identity? This is the question. What smallest number should I take here so that I obtain identity, right? So let's see. So you see, if you take 4 x raised to power 4 raised to power 1, what do you get? You get x raised to power 4. So no result here. If you take it as 2, you get x raised to power 8. So nothing we can conclude here. If you take it 3, then you obtain x raised to power 12, and we have a result for 12. Why? Because if x raised to power 6 is e, then x raised to power 12 could also be written like this, right, which is e square, which is also e, hence you have this as equal to e. Hence if you take x raised to power 4 power as 3, then you get identity, therefore the order of x raised to power 4 is 3. In a similar fashion, we will be looking for x raised to power 5. Now basically what is our task? Our task is that we wanted to look at some power of x raised to power 5 such that it becomes identity, correct? So if we substitute 1 here, so we get the power as 1, so we do not get anything. If you put 2 here, you get 10, you do not get anything. You put 3 here, you get 15, you do not get identity. If you take 4, you get 20, you do not get identity. 5, 25, so you won't get identity. What about 6? On 6, you get it as x raised to power 30, and 30 is a multiple of 6. So you can write it like this, 6 raised to power 5, correct? Hence it would become e raised to power 5, which is again e. Hence in this case you obtain the power, you obtain the answer as identity, hence the order in this case is x raised to power 5. Correct. So this is one part of the question. In the next part, they are saying if you have y, another element of the group, and the order of y is given to be 9, then you have to calculate the order of all the powers of y such that you start from 2 and go up to 8. Correct. So we are given y raised to power, the order of y is 9, so that means y raised to power 9 is e. This is given to us. Now for y square, we have to take that power of y square which give you identity. So clearly, because we have to look for all the multiples of 2 such that it is also a multiple of 9. So what is the result? The result is that you only have the choice as 9 here. You only have to take 18 here, the power 18. That could only be done. This is the lowest possible number. So you can write this as y raised to power 9 square, correct? And what is y raised to power 9? It is e, so it becomes e square and it is e. Hence the order here is 9. In this case, for y cube, you can write y cube as y cube raised to power 3. Why? Because it would become 9, and you know y raised to power 9 is identity, hence the order is 3. For y raised to power 4, you do not have any multiple, any common multiple of 4 and 9, hence you only have to take the power here as 9. No smaller number could be taken otherwise, correct? So this give you the order of y raised to power 4 as equal to 9. What about 5? Again, nothing in common, so you only have to take the number as 9, so it becomes identity. Again, for 6, yes, we have something which is a common multiple of 6 as well as 9. So you see what number is that? That is 18. 18 is divisible by 6 as well as 18 is divisible by 9 also, correct? So therefore in this case you can take the power as 3. It becomes 18. You can write 18 as 9 into 2, right? Y raised to power 9 is your e and e square is e. Hence the order here is 3. For 7, we do not have any common multiple with 9. Therefore in this case you only have to take the power as 9. Hence the order here is 9. What about 8 and 9? Again, nothing common in between, hence the order here is 9, correct? So in the next part of the question, they are asking you, do these examples suggest any relationship between the order of the power of the element and the order of the element itself? So you see, in this case we have the order of the element here as x6, correct? And the order of their powers is 3, 2, 3 and 6. So can you see anything, any relation in between them? And in the second example, we had the order of the element as equal to 9 and the order of its powers is 9, 3 and 9 only, right? So do you see any relationship? Yes, it is quite obvious that these order of the powers is basically nothing but the factors of this 9, which the numbers which divides this order, which is 9. Here also 2, 3 and 6, they divide 6. Here also 3 and 9, which divide 9. Hence you can say that it is quite clear that the order of power of an element is nothing but a prime factor of the order of the same element. You can you remove this prime from here. Why? Because it is not actually always a prime number, because you also get a 9 here, correct, and a 6 here in this particular case, right? So therefore you can say it is nothing but a factor of the order of the same element, or the order of power of an element. You can write it like this: a raised to power k, it divides the order of the element, which is a. Hence you can write it like this by the Euclid's division algorithm. You can write it like this: order of a is nothing but order of a raised to power k into some divisor d, right? This is the quotient here, and because it completely divides, the remainder in this case is 0. So we skip, I have skipped writing it. Okay, so this is the result which we observed in this case, and in fact this is actually a result which you shall be studying in cyclic groups. This result tell you that if you have the order of the element as this, right, which is, you can take it to be n also, right? So this is what the order of the power of the element is equal to the order of the element itself divided by the GCD of the order of the element with this power k, correct? So let's verify this result. Does it follow with our examples? So I am verifying it with our first example. In this case the order of the element is x, so here is 6, right? Our element is x. So in this case we have 6 everywhere, right? And here also we have 6. Now let's take one by one the case of x square first. If we are taking it to be the case of x square, so you have 2 here, right? And what is the GCD of 6 and 2? It is 2, so you have the answer as 3. So we obtained the answer as 3 in the previous case also, right? So this is verified. Similarly for the second power, now we take k as equal to 3. If you take k as equal to 3, you have 3 here, so that means you wanted to calculate 6 divided by the GCD of 6 with 3. The GCD of 6 with 3 is what? 3. So you have the answer as 2. And you already saw that the order of x cube is 2. Similarly, when you take k to be equal to what? 4, right? So let's see what do we have. If you take it as 4, so this becomes the GCD of 6 with 4 is 2, so the answer is 3, correct? So here also you see the answer is 3. So this is also verified. For the last case, when you have the value of k as equal to 5, what do you have? You have 5 here, 5 here. The GCD of 5 and 6, that is 1. They have nothing in common, so the answer is 6. So you have the order of x raised to power 5 as 6, and here also we had it as 6. Hence the result is verified in this case also. So I hope you understood this question. Well, that is it for this video. Thank you for watching.